All right. Hello, everyone. In this video, we're going to walk through the introduction of two loops in C#, the while loop and the do while loop. We'll briefly explain the difference between the two, and we'll build a little solution. So the objectives for this lesson will be to explain how to repeat code statements. That's the purpose of implementing loops in the first place. Sometimes, a program is pretty straightforward. You want to just perform a task and be done with it. But other times, you want to be able to repeat something multiple times, and this is where loops can help do that. Again, like I mentioned, we'll explain the difference between the two pre-test and post-test loops we have. So we have a while loop and a do while loop, and then we'll use those to build a solution really quickly. All right, let's get it. Okay, so here you can see, again, I've just pulled down a problem document from Moodle, so you can all grab this out of the exercise documents for week 4. The loop problems PDF, it's got a couple of problems in there that we can work with, and we'll use 2 of these over the next couple of videos that I'll put together. But the problem that I want to address in this particular document with you right now is the second one. So in this second question, we're being tasked to input a list of positive numbers and then calculate and display, it says here, the average age. So we can take it to mean that these positive numbers correspond with ages of people or dogs or who knows, ages nonetheless. And we're going to use the input of the number 0 to stop prompting for numbers. Okay, so this is the one line that kind of distinguishes this type of problem from the previous problems that we've seen before, in that we're not just being tasked with inputting something and displaying a result, or performing a very simple calculation and then displaying result. We're really being tasked here to repeatedly do a particular set of tasks or statements, and in this case, until the user chooses to stop. So this is an indication to us that we're going to have to use some type of repeating statement or a loop structure. Okay, and we'll get to that. And it turns out that the implementation of a looping structure is actually fairly straightforward, especially if you already have a really good grasp of the decision structures, specifically the if statements. But we'll see how that can be put to use here in this sample problem. So again, I'm going to go through our problem-solving process, where we'll first of all kind of just restate the problem here. So let's do that first. And a simple restatement here is, for me, it's, again, the problem statements in the practice exercise documents are not too complex. They're not intended to be that complex. They're there for you to learn, but we can still practice our skills in restating. So here, we could say something like, we're going to enter an unknown number of positive values. We want to, calculate the average of the values and display the average. Let's just leave it there. Okay, super simple. Now, if we want to, again, include somewhere in here the idea of like, okay, well, what are we dealing with in terms of values? Excuse me, allergy season. We can work to include that in our restatement of the problem as well. So we have an unknown number of positive values, but it will be known when we want to stop entering them. So we can say stop entering or accepting values when the user enters 0. Okay, awesome. Again, we could revisit that just to make sure we think we have a pretty good understanding of the problem, but I think that works pretty well. So again, when we try to model this, again, really simply, we're just going to, again, follow pretty much the same model that we've seen so far. So for example, I'll leave the title piece out, but we want to get value, okay? And the trick here is we're not just going to get a value once. right? We're going to repeat that multiple times. So again, if you have like a flow chart or something, it might be easier to diagram this, but I'm just going to do this quickly here in Word. So we're going to get a value, and I'm going to say here times n. Like, I don't know how many of those we're going to get. We're going to get a value, up to some n number of times. And then once we've gotten those values, then we're going to do a little process. We're going to calculate the average. Oops. Mic in the way here. And then we're going to display the average. Okay, so that's the model. So this is the piece here that's kind of new, right? Is, well, how are we going to do that? Well, I mean, let's not worry about it right now, but again, just taking that as a very simple model of the problem itself and applying that back onto our restatement, just to double check and confirm that we do have some understanding of what it is we're trying to do here. So we're going to get a value a number of times, right? Eventually we're going to calculate an average, and then we're going to display that particular average. So I think that captures it nicely. Okay, and then we can get into the planning piece, which is where we'll explore a little bit more about the looping structure that we're going to have to include here. So one thing that I often recommend to students starting out learning programming is, when it comes to these looping type problems, try not to go right away to a solution where you're just implementing the loop, okay? Because that can sometimes be a bit more difficult and tricky, given that you're still new to programming. You're probably still trying to figure out some of just the syntax quirks of the language and things like that. So what I often recommend is this idea, and it's kind of encapsulated in this model that I've just produced. We're going to have to get a value from the user, okay? We don't know how many times they're going to enter in a value, but we know they're going to enter a value at least once, right? Like even if it's just to say, I don't want to enter any values, given the problem statement, they're going to have to at least enter a 0. So rather than worry about this times n that we've put in our model, let's just make it work for one time, okay? If you can make the program work in the same way that we've created the programs to this point, as a sequence, just bang, 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 do the steps and then end. So get a value, calculate an average, and display the average. Of course, the average will just be the input value, but that's fine. If we can get that to work, then we can revisit it and then just focus on the problem of, how do we repeat the statements that we want to repeat, okay? Again, you don't have to do it that way, but that's what I'm going to recommend, at least when you're starting out, is forget about the looping piece for a moment. Just get it so that it does something once, and then revisit it and talk about and think about and plan for how you're going to repeat those statements that need repeating. So let's just kind of go from the top. We're going to be inputting a value. It's an age from the looks of it, so we'll go with the default integer value for that. So I'm going to declare, I'll just call it value, as an integer. Okay, that's fantastic. And then we're going to, I'll just say here, display a program title, awesome. And then we're going to have to prompt, I'll just say enter an age. Okay, and we'll store that in value. We could call it age or whatever. Okay, now this is where we're going to have to apply some thought. So after we get our age, we need to calculate an average. So the thing that we need to think about here is, how do we calculate an average, right? Or a mean average. What do we need to do that? Okay, and the pieces of calculating a mean average are we need a sum. So like, what is the whole sum of the values that have been entered? And we need to divide that by the count of the entries, right? Or the number of values that were entered. So we need a sum, and we also need a count. And those are two things that are not explicit in the problem statement, right? They're implicit in that we're being asked to calculate the average, but we now have to step back and think, okay, well, how are we going to do that? Are there additional pieces that we need to solve this problem? So we're going to have to somehow track and keep a running total of the ages or the values that are being entered. And we're also going to have to keep a count of how many of those have been entered so that we can do our average calculation. Now, some people will come up with a solution where they're trying to keep count of the average or track of the average as the values are entered. But I'm going to do it in this way just because it's a bit, I think, more straightforward and simpler for people to understand a straightaway calculation rather than trying to do it on the fly as we enter values. Okay, so we're going to have to include a couple of additional variables. We need a sum. We also need a count so that we can go about calculating this average. So in addition to our value, we're going to declare our sum. Since we're entering integers, the sum is also going to be an integer, and we're going to have some kind of a count of how many. Well, that's going to be a discrete count, right? 1, 2, 3. So that can also be integer values. So we can declare, I'll just call it count as integer. And the one thing to keep in mind about the count is every time a value is entered, we're going to add 1 to the count, right? So as soon as we enter our first value, that's 1. If we enter our second, 2, 3, etc. So we're going to be adding to that variable. So it would be good for us to explicitly initialize this count to a value that's known before the program begins running. So I'm going to say here that we're going to declare the count as an integer, but we're going to initialize it to the value 0. And so that way when we first enter a value, we know we can add 1 plus 0, and that'll put it to 1. And then the next time through, 1 plus 1 would be 2, and 2 plus 1 would be 3, etc., etc. But it's good to initialize count variables in this way so that we explicitly know where those variables begin. And so when we start adding or subtracting or doing whatever we need to do with them, we know for certain exactly how things are going to start off. So once we've got these, right, we're going to have a sum, we're going to have a count. We also then need the average if we want to save that as a variable. We could put the expression in an output, but it might be a good idea to just do it this way. So we'll declare the average also as an integer. Okay, and so now we can get rid of this. We've kind of thought about it a little bit. Once we prompt for the age value, right, well, what do we need to do with that? That value's got to be added to our running total or to our sum. So once we prompt for the value, we can set our sum, and this is another good point. Sum is assigned itself plus whatever the value is, because we're trying to keep track of the running total. So we're always going to be adding to the current value of the sum. And again, here we can see explicitly, well, the first time we do this, what is the value of sum? So if the user enters in a value of 20, what are we adding the 20 to? And so this is another good case for, oh, you know what? This is something we're going to be adding to explicitly. We should probably initialize that as well. And the sum should begin at 0. We haven't added anything to it yet. We should initialize it to 0 so that when we start adding, this makes sense. Okay. Again, this is something that a lot of times people that are new to programming or students, they'll forget this. You'll write your solution out and then there'll be some kind of an issue, and it's just due to the fact that a variable wasn't initialized. So as you're typing these statements out in your plan, ask yourself these questions like, well, what would happen the first time? Like, what does this look like? Even if you're not doing that, again, if you create a test plan and run through that, you should see these types of problems crop up if you've developed a test plan in the appropriate way. So once we've asked for the value, we can add that value to the sum, but then we also need to keep track of, okay, well, we've just entered a value, so that's in addition to the count. So we're also going to want to set our count in the same way, equal to itself, but here we're not adding a value, we're adding just 1. So the count in the first case will go from 0 plus 1 to 1. So we'll do the expression on the right and assign to the left. Okay? And so once we've got those three things, we've prompted for a value, we've added to the sum, and we've increased our count, we should then be able to do our average calculation. So our average is going to be assigned the sum oops, there we go, divided by the count. Okay, simple mean average calculation, no big deal. And then finally, we can display something like the average of the values is, and then, oops, we just put the sum, or the average, sorry. Average, okay? And so that's it. It's a pretty simple program in a way. And again, it's not intended to be complex. It's here as a practice mechanism for you to just work on really the looping piece of it. So the problem itself isn't intended to be very, very difficult, but it's enough for us to really stop and have to think about it a little bit and make sure we've accounted for all the moving parts. But now we're ready to get to kind of the real meat and potatoes of it, which is, okay, this is okay. We can run through and give it a test, but then we're going to want to make sure that we implement the times n. This is the new piece here. So we're going to declare our variables. Awesome. We're going to say, hey, welcome to the average age calculation program, whatever. And then we're going to say enter, an age. Okay, great. And then we're going to enter that value. We're going to add it to the sum. So if they entered in 20, 0 plus 20 would be 20. We're going to take our count. 0 plus 1 is 1. Our average in this case would be 20 divided by 1, which is 20, which makes sense. We only have the one value, so the average should be equal to that value. And then we're going to display it. Okay, so it's pretty quick. I'm not going to work through a test plan, again, in this case for time's sake, but we could implement that in a table very quickly, run through our plan as it is here, and then say, okay, I feel confident that we can go ahead and execute this. So in my test plan of entering a value of 20, I would expect to see that the average value is 20. So let's go ahead and code this as it is, and then we'll come back and we'll implement the looping piece. So we don't need this anymore. I've got Visual Studio open here. I'm going to create a new project for this. It's a console application. I'm going to call this lesson 3. Oops. And I'm going to call it loops. And create. And we'll implement this solution using both, like I said, the pretest, the while loop, as well as the post-test or do while. So we have basically one solution that demonstrates both of those looping structures. Okay, again, the nice thing about having a plan, if it sounds like I'm a broken record, you're right, I can't stress this enough. The nice thing is we're not now wondering what to do. It's, oh, here's what we're going to do. Here are our statements. We're just going to translate these one for one over here to Visual Studio. So pretty straightforward. So we've got a couple of int values. So int, we have value. Okay. And then we've got the sum, which is initialized to 0. We're going to have our count, which is also initialized to 0. And we're going to have our average, which we don't need to initialize. We're going to calculate that as a value later on, so no worries there. Okay, we're going to display a program title. Again, I'll keep this really short for this example. So I'll just call it average values. Can't be much more explicit than that. Awesome. Okay. And then a right line just to, oops. There we go. Okay, so we've taken care of this part. Declared our variables, we've displayed a program title, and now we can get into our prompting piece. So our console, we're going to write our prompt. So enter a value, and then we're going to get that value. So the value is going to be input from an int parse, because the console read line only gives us a string. There we go. Okay, so that takes care of our prompting piece, and now we can get into our calculations. So The sum is going to be assigned its current value plus the value that was entered, and we're going to increase our count. So our count is going to be assigned its current value plus 1. Okay, finally, we can do our average calculation. So the average is going to be equal to the sum divided by the count. And then finally, we're going to do our display. I'll use a string interpolation to do this. And it says the average of values is, oops, average. Okay, it's an integer value, so we don't need to do any formatting or anything like that. It's pretty straightforward. Okay, so save this. Again, take account of what we've just created as code. Have a look at how that aligns with our plan. Again, it's line for line for the most part. Good. We can give this a quick run through to see how this is going to perform. Right, so if we enter in a value of 20, I would expect to see 20. Awesome, fantastic. Okay, so at this point, we've run through this entire program. Again, this should all feel pretty familiar by this point. You should have already created probably about 10 to 12 individual programs on your own, and they should all feel pretty similar to this, right? Declare some variables, display a title, do a prompt, simple arithmetic expression, display the result. So this is all just practice review, which is good to do, but there's nothing new here. Now we can come back, considering that all works, and like I said, stick with what's familiar, and now we can deal with the new part, the unfamiliar piece, which is how do we get the repeating statements. Okay, so again, we've got two structures that we can implement here. We've got a while loop and we've got a do while loop. The major difference between the two is this particular fact. The body or the repeating statements of a do while loop will always be executed at least one time. Okay? And the reason for that is the test for the condition to determine whether or not we should execute the body of the loop is not tested until after the loop body, right? Hence the idea of it being a post-test or post-condition loop. We do what the repeated statements are, and then we ask the question, should this be repeated again? Okay, so a do while, you'll always get the loop body at least one time. A while loop, or a pre-test or precondition loop, tests the condition first, right? So before we do anything, we say, should we do this potentially repeated statement? Should we do it at all? And the answer from the condition might be no, right? So we may never execute the body of a pre-test or precondition loop, okay? And so that is the major difference. A pre-test will execute 0 or more times, and a post-test will execute at least once and then potentially more times. Now, in this problem, sometimes that matters, right? If you potentially want to do something 0 or more times, that's going to right away limit your options, okay? Unless you do some type of decision structure where you have an if decision before the do loop, which can work depending on how you want to frame your prompts and your error messaging. But if you can straight away identify that you're going to do something at least once or more times, then either of those are available. The pretest, therefore, because the pretest or the while loop can execute 0 or more, which necessarily includes 1, because 0 is before 1, you can solve any of the repetition or looping style problems that you face with the while loop, okay, with the precondition loop. You can't just by default solve any and all repetition style problems with the post test or the do while loop because it does not have that 0 option, okay? Now, in this problem, we're going to be asking the user for a value at least once, potentially more times, so either of those are available, okay? And what I'll do is we'll create the solution using 1, and then we'll just comment that chunk out, and then we'll implement the solution using the other style of loop so that they're both included in your code. You could add any additional comments that you might want to put in notes or things to remind yourself of what the differences are. But I like to have, as a first learning program, a solution that has both solutions in it or both types of loops so that you can see it. So before we implement either of those, what we need to do is, first of all, identify what are the repeated statements in the program. And again, if we go back up to our model of it, it's really on this piece here, right? The getting of the value in. Now, included in that are also some other pieces, but this is the big piece. So this prompting statement here, this is what we want to repeatedly do. We want to ask them for a value and then ask them for another value. And every time we ask for a value, we're going to add that value to the sum and we're going to increment the count. So these three tasks, these are the repeated tasks. Okay, we could also on every single pass calculate the average, but that's just an additional step, right? I don't want to repeatedly calculate the average. I want to repeatedly get values, okay? So these are the three steps that we want to repeatedly do. And then the question is, well, how long, like until when? When do we stop doing them? And that is until the user enters a value of 0. So we know what the condition is, right? We're going to ask for these values, and then when the user enters a value of 0, we want to stop. Okay, that's going to require a little bit more tweaking, because when they enter that value of 0, we'll take that to mean that it is not a valid age, and therefore we don't want to add it to the count or to the sum. It doesn't have an effect on the sum, but we definitely don't want it to affect the count. So there's a couple of ways we can deal with that, and again, I'll walk you through several of those. So identifying this, what we need to do is say, okay, these statements are going to be repeated. So what I'm going to do here is I'm just going to tab those in my plan, and I'm going to surround these with a structure that indicates we're going to loop it. Okay, we'll do the first solution here with the do while solution piece. Okay, so we'll start off with the post condition loop. We know we're going to do it at least once, so we'll see what that looks like. So I'm just going to say here we're going to do the following, and at the end here, we're going to do this while something is the case. And in this example, we're going to continue to do this while the value that was entered, right? If 0 indicates to stop, then I want to keep doing this while the value is not 0. So we can use a not equals 0 condition. So do the following. We're going to ask them for the value. They're going to enter it. We're going to add that to the sum. We're going to increment the count. And here with the condition, while the value is not equal to 0, if that's true, then the execution is going to jump right up back to the top of the do, and we're going to jump in here and repeat it. Okay? So this is the whole magic. It's really going to be these two letters, do, and then the condition at the end that get your code to repeat. So like I said at the very beginning of the video, there isn't a lot to it. It's pretty simple to implement. The more difficult part is, where do you implement it, and what is the condition, right? Those small pieces around the implementation of it. But the actual typing of code is very little. There's not a lot to do. So this is going to work, I think. Okay, so we can say do the following, enter this, add it to this, this, and that, and keep doing that while the value is not equal to 0. There really isn't anything else to say here, except that when the user enters a value of 0, we're going to add 0 to the sum, which does not affect the sum. That's fine, but we're going to increment the count by 1. And when the user enters the value of 0, we're going to take it as we don't want to include that as an age. That should not add to the count that we're going to use in the average calculation. So there are a couple of ways we can deal with this. One of them is the following. These two statements, right, we could combine them and say we only want to do these two, right? I only want to add the value to the sum and increment the count if the value is not equal to 0, this same condition. So we could wrap these two statements in an if block, and we only do it if the value is not 0, if that makes sense. Okay, so, and then we can leave everything else the same. So just to give you an idea of what that would look like, it would be the following. So if, the value is not equal to 0, then we're going to do these two statements. So enter an age. We can update this prompt to be a bit more clear. We'll say 0 to end. Okay. So when they enter a 0, is 0 not equal to 0? No, we don't do this. Is 0 not equal to 0? No. And then we jump out and calculate the average. The count and the sum are correct because we only added to them when the value was not equal to 0. Okay, so this is one potential solution. And it's the one that we'll implement since I have it here. Another potential solution is, and I'll just go back in time after to get rid of these, is to still do these things, right? So enter the value. If they enter 0, 0 onto the sum has no effect. And then increment the count by 1. And then out here, either decrease the count by 1, accounting for the fact that you included the 0, or do a count minus 1 here. So you could do something like this. And now, of course, division has a higher precedence than subtraction, so you would want to do something like the following. Okay, so that would do the same thing. It doesn't require us to put the if in here, but is not accurate. Okay, because the count as it's stored is actually one too many. So we're accounting for that here now in this expression. But if we wanted to display a count, let's say in the display here, in addition to displaying the average, we also wanted to say, there were 22 entered ages. We would then have to account for the count minus 1 in the display as well. And to me, I'd rather just have an accurate value in the count rather than having to subtract 1 every time I want to use it. So I'm going to roll with this particular solution for now. But like I said, experiment and try both and see how you feel. Both are valid. So if you submitted them to me, for example, as an assignment solution, I wouldn't grade either as wrong or necessarily even better than the other. I might make a comment to say these are some things to think about. But again, they work, they're valid, and that's the most important thing to me, at least for now while we're in this Intro to Programming course. So with these adjustments to the plan, we can go ahead now and bring those changes over to our code. So I'll show you how this looks in C# syntax. So these are the statements we want to repeat. We've identified those. Again, we wrap everything, keyword do, and we create a code block for the repeated statements. So we'll say do. We're going to tab these values in, and we're going to do those things while, again here, the value is not equal to 0. So again, it's pretty much one-to-one what our pseudocode plan is. And again, this is why I like to use pseudocode. It makes it a bit simpler when I go to do these implementations. Not all loops in all languages are do while. Some are do until or repeat until or something like that. But again, for us here, it actually works out pretty nicely. And so that's it. This is the implementation of the repeating piece of our solution. If we were to execute the program now, we would stay in this loop or expect to stay in this loop and continue to repeat this code statement. So here's the block. It begins on line 19. It ends on line 27. We're going to display a prompt. We're going to input a value. We're going to add that value to the sum, and we're going to increment the count. Oops. And then I accidentally included the average, which I stress so much I don't want to do. So let's make the update there. That's why it's good to review our code. There we go. And we're going to continue to do these statements while this is true. Okay, so that's how we read it. Do this while this condition is true. It's not do this until. A lot of times people will see post-condition loops set up as do untils. And we could have written it that way. So we could say something, instead of here, do while the value is not equal to 0, we would write this as do until the value equals 0. But that wouldn't be the same as what we would do here because we don't have a do until style logical loop where we do it while something is true. So we would have to, kind of reverse the condition. So just keep that in mind. If you, in your mind, when it comes to planning, are thinking more about do this until the value equals 0, that's totally fine. You can create your plan in that way, but just know that when you go to implement it in C#, you're going to have to rethink what you're doing with that piece of logic, okay? So do until value equals 0 is going to be implemented as do while the value is not equal to 0. And so that's that. The one final piece we can add here as well is the addition of our check. So we can say if the value is, again, not equal to 0. It's a bit redundant, but that's fine. We want to do these two things. Right? So we enter the value. If it's not 0, add on, and then everything else stays the same. So let's just give this the same kind of a test again. Oh, let's update our prompt as well. So we'll say 0 to end. And let's run this. Save and run. And so I would expect from my first test case that nothing has changed. So if we enter in a value of 20, I should still get an average of 20, but I shouldn't see the average right away now because 20 is not 0. I would expect to see a reprompt. And here we go. So we've entered in the value of 20. Okay, so that was entered. Value was not equal to 0, so I would expect the sum to be incremented to 20, the count to be incremented to 1, and 20 is, in fact, not equal to 0. That's true. So while true, we've come back up and we see our prompt. Now if I enter in 0, I would expect to not increment the sum, not increment the count, and this is not true. 0 is, in fact, equal to 0. We should exit the loop, calculate an average, and then display the average of 20 to the screen, and that's what we see here. Okay, and then again, you can run through and test this multiple times. Again, if you've gone through the debugging video that I've shown, we could set up some breakpoints, so we could walk through exactly how this looks in our code, and you could step through these statements. Oops, we'll get rid of that. And yeah, have some fun with it. Do some practice. That's the best way to get better at this kind of thing. So let's just run through this one more time to see, maybe with several values. If I enter a value of let's say 40, if I actually hit my numlock key, that would be helpful. So exceptions is something we'll deal with later on, but for now we haven't quite got there. So let's do a value of 40, and let's do a value of 20, and then a 0, and my average should be 30, and it is. Okay, so again, we would have some kind of a test plan that we would put together for input, expected output, actual output. But again, for the sake of time, I've just kind of skipped that step so we can get to our coding. But in my mind, it's a pretty simple problem. I can run through with some test values, and we can see that it actually works. Now, one thing that we haven't taken into account is something that I recommended as a challenge in a previous lecture, which is, well, what if the user enters in like negative values? Because the original problem, if you remember, was pretty explicit in that it was asking for positive values only. So what if the user enters in a negative value, right? Either you would just simply not do this again, you would need some kind of other conditional check. Maybe you would want to show the user some kind of an error message or something like that. So we can come back and revisit a problem like this when it does come to dealing with exception handling and error handling, and we'll walk through how to use loops to reprompt for inputs. But if you want to practice between now and when that lecture video happens, please, that's the challenge I would put to you is, if the user enters in a value that's negative, since we're only looking for positive values, how would you go about displaying an appropriate error message to the user and then reprompting for an input value? Again, there are a number of ways to implement that as a solution, and I would put it to you as an exercise to try to work through at least one potential solution, if not identifying multiples, and then trying to test or determine which one you like or see as being a better solution than another one. Okay, so like I said, I wanted to show both. This is our initial do while example, but I also want to show you how you would implement this as a precondition loop. And the funny thing about it is it's pretty straightforward. It's effectively the same thing. So if we wanted to do this as a precondition loop, we've got to make one small change. The while condition is not going to happen at the end, right? It's not going to be post, right, loop. It's going to be pre-loop. So we basically just take this while chunk and cut it from here, and we replace our do with that. And then this becomes just simply end while. And so now our condition is seen first. But this is going to change a little bit of the way we think about our program too, because in the previous solution, I knew that when we got to the condition here, we've already input a value into the variable. But in this example now, the first time we come through our code statements and see this condition, the value hasn't been entered yet. So to ensure that this is going to allow the code to go in, we need to now make sure that the value is in fact not equal to 0. So we would have to initialize value to some number that is not 0 to allow it to go in to the condition. Okay, and so this is what I was saying at the very beginning. We have both these loop structures available. We have do while and we have while, post-test and pre-test, and they both serve kind of better case scenarios, right? There are pros and cons to using them. The while loop is versatile. We can use it for everything, but it's not always the best. And so I would, again, recommend you to consider if you have a problem that you're facing that's similar to this one, where you can identify the statements you're going to repeat will be done at least once, then you may want to implement that using the post condition loop. Okay? If it's not, then you can use the while loop. But in this case, as we can see here, to ensure that the value is in fact not 0, which is our default in C#, we need to first initialize it. So the solution here is going to look a little bit different if we do it this way. Okay? We would, first of all, either have to initialize or update this value. So ensure that the value is, it doesn't matter what you choose. I'll just choose 99. But we need to basically ensure that the value is not 0 to get into the loop, right? We need, it can't, this has got to be true in order for us to even ask for the first age. But if it's 0 the first time we get here, we would completely skip over this loop structure, and we would just try to get here, which would be a 0 divided by 0, which is a problem unto itself, and then we wouldn't even get to the display because it wouldn't work. So we need to be very careful when we make this change. So let me do this. I'm going to copy this, okay, and there are a couple of ways to comment your code out in the editor. In Mac here, a command / will do it. If you're on Windows, I believe it's Control K C, that will do it. But I'm just going to comment this chunk out. Again, you could use a block comment for that too. And then we'll have the while version of this available too. So Control X. And then up here where it says do, this is where we will replace our condition. So this is it. This is the change that we need to implement. So here's our do while solution. But our while solution, again, just to kind of group it together, is also going to require the initialization of the value to something to make sure that this is true the first time. And so this is where something like an inline comment might make sense. Like I put in the previous planning stage, we might say init to 0 to enter the loop, right? That's required, because if this were 0 or unknown, it would not do what we would expect it to do at this place in time. So here's a solution to a problem that has both the do while and the while implementations of loops in it for you to play around with. And then again, like I said, this is just one way to do the problem. I've identified some ways you might go about altering it, and I would encourage you to do so. Let's just run through this one more time to see how this is going to work. I would expect the same output as before. So we got into the loop, which is fantastic. We enter our two values and then a 0. I'd expect 30. So it works exactly the same. So from the user's perspective, right, it makes no difference how you've implemented this. And that goes back to what I was mentioning earlier, where I'm not going to say one is better than the other. I might have a comment to say, hey, you wouldn't have to do that if you use this type of a solution. But this is not wrong. Okay, this is a valid solution. It works. Is it the best? I mean, that's debatable. But we can certainly agree that it works. There's no reason to have to change it. And that's kind of what I'm interested in, like I said, when it comes to your solutions to problems. Okay, so that's it. That's our introduction to both the do while and the while loop. Again, I would encourage you to work through the remaining problems. There are 3 looping problem documents at least that are available for you to work through. I would hit those up. The looping topic, this is where some students, if they're not on top of the workload to this point, start to struggle a little bit. And the more practice you do, the easier it's going to be. If you can really get a good grasp of the looping structures moving forward, you're going to be fine. If you're struggling through the looping structures and you're still struggling with them when we hit the next topics, it's going to start to get a little bit difficult. So reach out to your instructor, reach out to your peers. If there's tutor help available, really put the time in and focus on this particular lesson, because like I said, it is definitely going to help you out in the long term and make the remainder of the course less of a challenge if you can lock this up sooner rather than later. So, okay, that's it for this example. We'll see you next time.